My name is Ilya Kosmodemiansky. I'm working for PostgreSQL Consulting, and actually will present you some bad things, what you're supposed not to do. Yesterday, you probably saw at the Lightning Talks, many people really do bad things. Probably one and every except Jim Nasby. Probably that's why he is not here, because he is quite resistant about the PostgreSQL worst practices. In general, first of all, why it is PostgreSQL worst practices at Postgres Open? Because usually it's a new version of the talk, because there are lots of worst practices and I need to select. Excuse me, can you please start the timer? Thank you. Basically, why PostgreSQL? Yeah, many of those things connected with Postgres, but in general, I was talking about database worst practices. But some of them will be very, very Postgres specific, and you probably recognize some stories from your life. Why worst practices instead of best practices? Best practices are quite boring. People do not want to follow them. Yes, there are some exceptions. Probably if someone says, okay, Facebook will never use transactions since 2017, I'm sure many people will follow that bad practice. Best practice. But if their advice will be some really good, probably no one will follow. So to entertain people and to educate in some way, it's better to describe some really bad, some worst practices. So everyone recognize that, okay, I did that last year. That's a bit funny, but yeah, maybe I will not try to repeat that. Only worst practices allows you really screw the things up. And another problem is that then you're working with customers on database support. You see those things 1 time, 2 times, 10 times, 100 times, 1,000 times every day, or something like that. So people tend to repeat those things. And besides of that, if I teach you something really bad, I do good for the people who supports Postgres and to people who works as PostgreSQL consultants, because they are nice people, you need to support them, so they will have their job. Because if everyone works well, they lose their job. That's bad. So how it works? I have some list, about 100, slightly more worst practices. That's not the thing I just created in my mind. It's everything the real life cases. I reshuffle that in honest and untransparent manner because some of the worst practices I like more than others, and then present you in some amount. Today it will be about 15, I hope so. And so, shall we start? The first one is one of the loveliest worst practices with Postgres. You need to as many count on, for example, the main page of your internet site with lots of client requests on the main page, maybe 10 of them. Because in highly concurrent environment, if you show such a figure like you see in the first line, it's very informative for people to see those figures. And if it changes just then they refresh the page of the browser, it's even more informative to have another thing. So use count as many as you can, because select count is not very costly thing for Postgres. Postgres will not scan the table and not check the version of every row in this table if you run select count. Just forget about that. That's a good practice. Use select count. If someone says you, okay, use pgcatalog, write the stored procedure just to retrieve from the pgcatalog row estimation, you always need to answer, that's not so precise, I will not do that. I need very precise count. The second one is very trendy one. The trend is NoSQL, no schema, so probably you will not want to program any boring schema at all, because, yeah, schema it's yesterday, it's not today, it's not the future. So basically you need one table, 2 columns, ID, and some extra, or you can call that metadata or something like that. Just single JSONB field, which is filled with different unstructured data. If you follow this worst practice, you need to keep in mind that JSONB is very efficient in PostgreSQL. That's true. And if you put megabytes and megabytes of JSONB, it will be the same speed of access if you create the proper table with proper data types, with proper relational design, that will be basically the same. You can use gene index for that, or maybe more than only gene index, or do not use any index at all. That will be just working as you're supposed to. Everything will be finally in the toast. You will have no any problems with Autovacuum in toast, no any particular problems. So just take it and use it. I don't know why different data types except JSONB are not deprecated in Postgres now. Maybe because Postgres developers are very lazy and very conservative. They are not agree to remove different things. Like, Postgres is very slow in its development, so that's why. It's my only guess. But a good question is, how many tables do you actually need? Your ideas. How many tables do you need if you decide to create this schema instead of my advice? One, it's this bad practice. There are plenty of worst practices. How many? How many? And I know the answer. You need 3 tables. Entity, attribute, and value. Then I supporting customers, I really like those because you can sell lots of hours of support if you have a customer with EF architecture. Because you need to be universal. This is a very universal system. You have entity, attribute, and value, and doing something like this. This is very universal. At some point, you probably will realize that 3 tables are still not enough, because not one and every attribute has the same type of value, and it's a little bit stupid to put it in the text field. Or maybe you want some kind of constraints or something like that, some constraints on steroids. And then you add the table number 4. And you call that attribute type. So this universal thing trending to be more and more universal. And finally, everything will be very, very slow. At that point, you should rename those tables to something like the system's core or the system kernel or something like that. Then you add lots and lots of tables with denormalized data just to keep accessing those data, because it will be very slow to access to huge EF core. And that's probably you're done, because it will be really and really slow. And finally, if it's not still enough, you can try to version their attribute values, because it's very convenient to have some kind of version control for all the story of your database. That's actually how many enterprise systems are designed. And that's why so many people are very enthusiastic about supporting those systems, because they are unsupportable. Then the system is unsupportable, it's a very good idea to support the system. Yeah, you know what I mean. But I'm just not I'm saying not exactly the true. Because from time to time, people do follow the best practices. And in that case, one of the best practices developers usually follow is that you must use indexes. And if you use indexes, you need to create as many indexes as you can, because indexing everything is a good practice. Because indexes do not consume disk space. They do not consume shared memory. Then you try to modify something in the table. Index do not add any overhead on modifying this table. And optimizer will definitely choose those index for those query if you just edit that. You do not ever try to check if once upon a time optimizer exactly use those indexes. That's not a good idea. Just keep calm, add more indexes, and everything will be quite okay. So this is a really good practice. Now we change to one of my favorite groups of worst practices. Actually, all of them are my favorite, but especially I like those which are connected with so-called big data, which Simon Riggs explained just before me. First of all, if you have some time series data, some collection of logs, some collection of statistics, some collection of session history, whatever, for several years, just keep it all. You need to keep it on your OLTP database, because, you know, it's a bad idea to aggregate that. It's a bad idea to have a retention policy to remove those data. It's a bad idea to remove it. You just need to keep it. Your business usually can tell you, okay, we need to have statistics for everything for years on the OLTP databases. And you never ever should explain to business that actually you are using just aggregates. So basically you can keep 1 month the aggregates and some kind of archive, probably on another database. That will be very stupid, because if you have such time series data in your OLTP database, it brings you some certain benefits. For example, you will definitely know where you should check, then you run out of disk space. Those are probably those tables, so do not bother with proper troubleshooting of Postgres. You just need to go to check if the log table, web access table, or something like that grew up to half a database, and you just need to remove data and so on and so on. That's a benefit. Another benefit, you can call that big data. That is actually the general recipe how you run into big data. Just not delete unnecessary data. That's a universal recipe. And you can solve those problems using partitioning, because using partitioning is the best practice. Partitioning will automatically help you. Because if you choose the proper resolution, for example, 1 minute, 1 hour, or something like that, in several months, you will have more than 1,000 partitions probably. And that's a good approach, because the PostgreSQL optimizer can use thousands of partitions quite easily. It will be fast, no overhead. You know what I mean. So just try to use partitioning for that purpose, and never rotate partitions, never remove them. That will be very good. Another my favorite big data issues is turning Autovacuum off, or just not proper tune Autovacuum. Because, you know, what is Autovacuum basically is? It's the stupid auxiliary process which only bothers you, because it runs for hours, sometimes for days, and the simple human reaction is just to kill that -9 and everything will be okay. So you basically will have for 10 gigabytes of data, the size of database several terabytes, and everything will be okay. Servers are cheap now. Memory is cheap, and the I/O is not a problem in Postgres or in any other database. So just do that, and once again, that will be big data. Everything will respect you. So you have big data, that's good. Another good idea is actually to kill Autovacuum processes if the process is taking too long time, because Autovacuum is not the kind of the task which you can actually postpone. So if you kill the Autovacuum process, it will start again in some time, and it will finish faster than before you killed that. So just keep doing that. That's good. Another my favorite, actually. If you try to replicate data in some way, you just need to reinvent the Slowney. Because built-in replication in Postgres is bad. It is asynchronous in some way. Synchronous replication has lots of issues. You have that slug. You need to write the script in Python or Go and something like that, retrieve write-ahead logs, apply in some manner, or just use some trigger-based application. Why? Because it gives you an opportunity. And this is an incredible opportunity that allows you to run into all problems Postgres run into since Slowney were introduced. If someone remembers how first Slowney was in operations, you definitely do not listen to that man, because then you have no opportunity to learn those things. So just take it and re-implement. Another my favorite. I don't know. I actually do not have any not favorite here. You know some application development programming language, and it is good, it's progressive. Postgres is old and very awkward, yeah, it's stupid SQL, stupid storage procedures, this awkward syntax sugar, begin, commit, rollback, and so on. That's really boring. So you need to basically select every data in the table, retrieve that to your favorite programming language, and then you can join that on the application level. Probably you will run into some small obstacles. Those obstacles are you will need to implement join methods, basically, because they're designed for different things. To choose the proper join method, you will need to implement optimizer. Maybe basically you need to implement some kind of executor, page cache, workmem, and so on. So just try to implement that on your favorite, using your favorite programming language, and you can see how easy it will be in comparison to normal Postgres. So simple join is several lines of code. I think in Python or Perl or whatever, it will be slightly longer. Again, you can be very productive. You can write a lot of code. That's good. Never use graphical monitoring. Because you have command line tools, you have grep, you have logs. If you have a graphical monitoring and your boss asks you, okay, what was happening last night? You can answer him immediately. He will think you're working not very hard, because it's really easy to say what happened in some time in the past. Then you have a graphical monitoring and can trace the trend and what's going on. So try never use graphical monitoring. That's a really good idea. Number 10. That's actually a very eternal question. Consistency at the application level is a very universal thing. So you never will mistaken if you choose that way. The good idea is to batch your salary for that. So if someone finds some inconsistency, then you not use foreign case. Probably you will give him his salary, your salary. Yeah, that's a good idea. No one actually tried that in my experience. So do not use foreign case. They are quite boring. Always use text column for everything because it's much simple. Those boring data types, they are int, begin, some stupid things. It's very easy to validate if IP address is a correct one, and you just can write some piece of code on Python or PHP or Perl to validate if this IP address belongs to those network mask and so on. That's easy. And if you try to convert the timestamp using a text field, that will be working quite always. So no nulls, undef, and so on. So just use text type. About data types, actually has another worst practice, which I did not include in this presentation. If you try to count money in some billing system or something like that, just use as many numeric data types as you can. 10 to 12, that's perfect, because the mistake of your money counting will be quite nice in that case. So just do that. Data types is really a good source of worst practice. Maybe it can be a single talk about the worst practices using data types. Postgres likes long transactions. Like any MVCC database, it's really good to have long transactions in Postgres. Always call external services like sending emails, going to the remote web service from the storage procedures. Probably you argue that it's a normal practice to use that because it's convenient, you can control everything. Why for God's sake, it's a worst practice? Well, it is arguable if the 100% of developers will know the word timeout. From my experience, maybe 1% knew it. Actually, it's a very good idea. Then you start the transaction and you send mail working for 4 hours, and then you commit your transaction. That's good. You simply can do that. You can start transaction and go for a weekend. Postgres will never run into problems with that because there is no such issue like freeze, 32 bits transaction ID, Autovacuum, so everything will be okay. You probably will know that because someone called you. Probably not. So some element of good luck is a very good thing for DBAs and all people who work with databases. So enjoy those things. That's really good. Put a synchronous replica to remote data center. Why? Because using synchronous replica, you usually assume you're maximizing availability of your project. Then it allows you to lose your master as fast as it can be, because before the transaction is applied on the replica in the remote data center, you cannot commit the transaction on the master. So basically, all your cluster is not so high available if it has a synchronous replica in remote data center. Because the channels usually are quite reliable and good, you definitely will benefit from this worst practice, and your project will be very high available. Especially you can put that on another continent. One Endeavor transaction will be pretty much faster than, and you only benefit from that. Once again, load your data to Postgres in a smart manner. Take your favorite programming language like Java, Python, or something like that. Parallel threads and try to insert or update as many data as you can. That is smart because everyone knows that parallel execution is for the speed. As a special idea, you can use Python with coroutines for that. That will be incredibly smart. And once again, never try to use for that purpose the command copy. Why? Because it's specially designed for that case. It will be unsmart to use that. So just try to reinvent the wheel. And probably the last worst practice, but a huge one, and as usual, a favorite one, is backup. Even after all those worst practices, you still want to back up your database, because actually if you try to follow the worst practices, you should never ever try to back up your database. Why, for God's sake? You have enough problems with all those practices. You can use replication instead of backup. This will allow you to lose your data in a very tricky and convenient way, because if you use replication as a backup, one and every person who has write access to your database can ruin your data effectively. He deletes something, drops something, and basically you have no backup, and the data is applied to the slave. And that's it. It's a good idea. Another good idea is to use pgdump instead of backup. Because backup in generally is the possibility to restore the state of your database up until the next successful successful transaction before the crash occurred. With pgdump, you probably will restore your database up until the moment that pgdump was dumped. So basically, you can lose 1 to 2 hours to several days to several weeks. I do not know how frequently you will do pgdump. To improve this worst practice, you need to do that once upon a week. In that case, you can lose a week of your data. That's usually a benefit. Another good approach which is probably repeating of some good experience Magnus Hagender explained 2 talks earlier, is write your own backup script. Because if you write your own backup script, it will be definitely better than any of existing backup script. And another good approach is to do that in most complicated manner. Possibly you want to combine several things. Honestly, I never saw a combination of built-in backup, Barman, and pgback rest. Maybe because the pgback rest it's not so widespread now, because the combination of built-in backup, Barman, and Hewlett-Packard Data Protector I already saw. So backup is the thing which should work in most unpredictable and difficult manner, especially the restore part of the backup restore. Because then you're trying to restore your data. You have plenty of time. Nobody tries to reach you by phone. Nobody tries to reach you by instant messenger. You need to sit, relax, and remember what kind of this custom script you produced 5 years ago. It is very simple and good idea to do that. And never ever perform a test recovery, because if you try to perform a test recovery at least once upon a week, you probably will lose. You will run into crash, then you take your backup, and then it will be recovered. That's definitely not the thing you want if you follow in worst practices. So never perform a test recovery at all. So basically, that's it. And I just want you to remember, because someone can download the slides and think that literally he must follow that practices. I once again repeat, those are worst practices. You do not want to do that. And probably at this point I might ask you, who recognized the common things in one of those worst practices? And who did not? That's a tricky thing. So anyway, if you have some questions or ideas, or you have stories to share, which I can include to the next talk like this, just drop me them. You need to mention if you want to be anonymous, because not many people want to share their experience of such way. But I try to be as discreet as possible about that. So if you have any questions, ask them. Thank you. Yeah.
I've got one for you. Okay. Timestamp column is very inefficient, because it stores the whole time. So we're going to encode the time in integer, again, to have a timestamp because it's just too difficult to, it's inefficient.
Actually, the one good practice is know your data. So if you're definitely sure that it's a good idea to store the data as Unix time, you need to store the data as Unix time. But in that case, you need to know how to work with this data, because if someone works with that using conversion to timestamp with time zone, another one will convert that to the timestamp without time zone, and so on and so on, you potentially can get lots of problems. So generally, if your performance requirements allow you to use timestamps, it's much more safer to use timestamps. If not, you can use Unix time, but yes, you need to know your data in that case.
Well, the point is that the timestamp is stored as an integer internally, right? So the idea of saving time by not storing it as an integer is obviously not important.
Yes.
If you want to be really, really sure that synchronous replication is disabled, also turn off fsync.
Oh yeah. You played this game before.
That will absolutely ensure that synchronous replication is not working.
Yeah, actually, with fsync, it's a good worst practice by itself, because I don't know for what purpose people do turn off fsync, but I never saw the people who would benefit from that. From time to time, people do benefit from turning synchronous commit to off. That works. But turning fsync to off, that's a very strange thing, actually.
See, because you have replication, you don't need fsync.
And pgdump.
So, but usually when I see it, it's performance. So like, oh, well, that makes the performance better, right? But in this case, they just wanted to make sure the synchronous replication was definitely not enabled. So they went and turned off everything that said sync.
One friend of mine actually called that the championship on writing into the memory. Because, yeah, you can compete and write into the memory, but the database is not for that purpose, probably.
Oh, definitely always put one of your table spaces on a RAM disk.
Oh, yes.
Yeah, that's a very
Another good idea is to put it partially to the temp disk. Not all of them.
Sorry?
You can partially put them on RAM disk, yeah.
Oh, yeah, just one.
Yeah.
Just one. Really confusing.
Yeah.
You can
PGC lock on RAM disk, yeah.
you can save making a lot of tables just by having a ton of columns. Lots of columns.
No. That's obsolete. That's obsolete because now you have JSON. It's more intermediate way to screw things up. Nobody can say that, oh, this guy using 1,000 columns in the table. For that purpose, JSONB was invented, actually. That they should be anonymized in some way.
And you can store different values in different columns based on the customer.
Let's use Hungarian notation.
The only security you need is obfuscation.
Oh yeah.
Not even column one, just C01.
Well, the column name should be random 8-character strings of just X and Z.
Oh, and bit mask your data. You got to make sure you put a text column with an integer in it that's a bit mask for 8 of your other fields.
Yes.
And so, other suggestions? So I actually basically can just reshuffle the half of those slides. Then you can add the other stories.
I have a question.
Yeah.
So many of those were bad practices for databases, any database, not Postgres specific, right?
Yeah.
Are there any that you think are, other than this fsync silliness, that are really specific to Postgres? So like, you assume that your database design, at a logical level, all that stuff is fine, right? Or those,
Okay.
in terms of running and operating a Postgres system, things that are specific to Postgres that you think you see as things that happen out there that are counterproductive or
I see many things of that kind. First thing is actually people that common for many databases, but for Postgres it's especially very important. People do forget to tune Linux or any operating system they run Postgres. For example, then XT4 was introduced. Lots of people were running Postgres with barrier enabled. And those write barriers are quite inefficient, especially if you have cache with battery or cache on SSD with capacitor and so on. So basically, if you enable barrier in that case, the performance drops very drastically. So that's a very common problem of real bottlenecks with Postgres today. Another thing is very Postgres specific also. Postgres do not have any kind of listener built in like Oracle has. So if you run out of the connections, you can just add some more connections, and finally you have 1,000 connections which are actually concurrently troubles each other. And in that case, you need to use PG bouncer. And actually, if you use Postgres in most cases, except of cases then you definitely knew what you're doing, you need to use PG bouncer. So running Postgres without PG bouncer, from my opinion, is a quite worst practice. Yeah.
Yeah, I think most people don't realize, or at least a lot of people coming from like MySQL or something with a threaded model, don't realize how expensive backends as processes are. Both to spin up and to maintain.
Yeah, definitely.
Oh, to answer his question about Postgres specific, you need lots of shared work room. Tons of shared, like gigs of shared work.
Yeah.
Because it should be as high as possible.
High as possible. More memory. Set it to like
And another incredible approach. Another incredible approach is actually to bring your experience from different database to Postgres. For example, you can bring your Oracle experience and set shared buffers to 40% from available RAM, like Oracle recommends with SGA. And that will be worst case of double caching for Postgres because it uses kernel buffer. And that's an incredible idea to implement on Postgres. Then you are familiar to SQL Server, you probably enjoy using temporary tables. It's incredible idea to create thousands of temporary tables in Postgres in storage procedure. You will run into a huge bunch of problems very effectively and very fast. So just to take the best practice from another database and implement it directly on Postgres is a very good idea to screw things up. Very efficient. Yeah. Yeah, that's a good result of those. Well, basically, the first problem is that it is not a backup because, yes, you're right, that's extremely slow restore, especially extremely slow dumping, especially for huge databases. But the most problem, it is not a backup. Then you have a true backup. You have some kind of inconsistent image and archived or write-ahead logs just to replay them and to put the database in consistent state. So basically, you can restore up to the last successful transaction. In case of pgdump, you only can restore to that moment where pgdump was made. So basically, you lose lots of data between your pgdump finished and the crash occurred. So that's why it's not backup. It's useful to have to still have a pgdump just to backup schema, for example.
It also is going to have to look at all your data, turn it into text, and then turn the text back into your data. So if you have any bugs or anything, you're not going to find it's going to fix. It's good in that it lets you like fix your data. But
Oh yes, oh yes, especially with encoding. Yes, because you, for example, you can forget to backup users because they are global in the cluster. It's easy to do that if you're experimenting with options in pgdump.
data will be like will denser and be in a different order, and like the new server might be.
Yeah. If you have some tricky extensions, for example, pgdump can just simply block them. So base backup too, to be honest, but not so often.
Just use cp-i for your archive. Cp-i is all you need. Use the example.
Yeah, sure. Another very good Postgres-specific problem is to find the option in the PostgreSQL conf and enable logging everything in the log to the statement. Yeah, it's incredibly good because yeah, you have lots of logs, lots of fsinks right in that. Big log for big data. Yeah. Yeah. That's a good idea too. Oh, another good practice is to try to read the data structure, or the structure of data tiers in PostgreSQL catalog literally. So some stupid pgex log. So it's stupid to remove write-ahead log, yes, but to remove pgex log, at least you can try. Yeah. So if no more questions, yeah, thank you for attending and have a nice evening.